This video is not affiliated with, endorsed by, or sponsored by the National Institute for Automotive Service Excellence, ASE. It is created solely for educational purposes to help viewers expand their automotive knowledge and prepare for ASE-style topics. For official information, study materials, and certification details, please refer directly to ASE.
Hey everyone, welcome back to the channel. Today we've got something really helpful lined up for you. 50 practice multiple-choice questions to test your knowledge and help you study smarter. Whether you're brushing up for an exam, preparing for a certification, or just wanting to strengthen your automotive skills, this video is designed to guide you step by step. Grab a notebook, follow along, and see how many you can get right. Let's dive in and start learning together.
1. A vehicle's front end rises when braking and dives excessively during acceleration. What is most likely worn? A. Shock absorbers. B. Stabilizer bar bushings. C. Ball joints. D. Control arms. Answer: A. Shock absorbers. Explanation: weak shocks can't dampen spring oscillations, causing excessive body movement under braking or acceleration. 2. A driver complains of excessive body roll in corners. Which component is most suspect? A. Stabilizer bar link bushings. B. Coil spring. C. Strut bearing. D. Ball joint. Answer: A. Stabilizer bar link bushings. Explanation: worn sway bar links or bushings reduce roll stiffness, allowing the body to lean excessively in turns. 3. A loud metallic clunk occurs when the vehicle goes over bumps. Which is least likely? A. Loose strut mount. B. Broken spring. C. Worn ball joint. D. Misaligned rear axle. Answer: D. Misaligned rear axle. Explanation: rear misalignment won't cause clunking. Noise indicates looseness or breakage in the front suspension. 4. A vehicle leans to the left even on flat ground. Cause: A. Weak left spring. B. Low tire pressure. C. Bent stabilizer bar. D. Overfilled power steering fluid. Answer: A. Weak left spring. Explanation: a sagging or broken spring on one side reduces ride height. 5. Excessive negative camber on one front wheel indicates A. Bent strut or spindle. B. Weak shock absorber. C. Loose tie rod. D. Incorrect toe. Answer: A. Bent strut or spindle. Explanation: structural damage to a strut or spindle changes wheel alignment geometry, affecting camber. 6. When performing a bounce test, the vehicle continues to oscillate more than twice. This indicates A. Weak shocks or struts. B. Broken spring. C. Uneven caster. D. Loose tie rods. The answer is A. Weak shocks or struts. Explanation: a properly damped suspension stops bouncing after one cycle. Continued movement means worn dampers. 7. A popping noise occurs when turning sharply at low speed. Most likely, A. Worn strut bearing plate. B. Weak stabilizer bar. C. Faulty control arm bushing. D. Loose steering wheel nut. The answer is A. Worn strut bearing plate. Explanation: strut bearings allow the spring to rotate with the strut. Wear causes popping as the spring binds. 8. A broken stabilizer bar link on one side will cause A. Pulling. B. Uneven tire wear. C. Excessive body roll. D. Steering wheel vibration. The answer is C. Excessive body roll. Explanation: the stabilizer bar cannot transfer load effectively if one link is broken. 9. A driver reports tire cupping. The root cause is often A. Overinflation. B. Worn shocks or struts. C. Incorrect toe. D. Bent wheel. The answer is B. Worn shocks or struts. Explanation: tire cupping results from bouncing tires due to poor damping. 10. The function of control arm bushings is to A. Support vehicle weight. B. Absorb road shock and isolate vibration. C. Limit wheel travel. D. Adjust camber angle. The answer is B. Absorb road shock and isolate vibration. Rubber bushings cushion movement and reduce noise and harshness. Number 11. A power steering system makes a groaning noise when turning. Fluid level is correct. Cause: A. Air in system. B. Loose belt. C. Low tire pressure. D. Bent tie rod. Answer: A. Air in system. Explanation: air bubbles cause cavitation and noise even with full fluid. Number 12. Excessive steering wheel play could result from A. Worn idler or pitman arm. B. Stiff upper strut mount. C. Excessive caster. D. Overinflated tires. Answer: A. Worn idler or pitman arm. Explanation: play in these linkage points delays wheel response. Number 13. Hard steering at low speeds can be caused by A. High tire pressure. B. Slipping power steering belt. C. Excessive tow out. D. Overfilled pump reservoir. Answer: B. Slipping power steering belt. Explanation: belt slip reduces hydraulic pressure, making steering effort higher. Number 14. A rack and pinion steering system feels stiff only in one direction. Likely cause: A. Binding inner tie rod. B. Faulty pump. C. Uneven caster. D. Steering shaft misalignment. Answer: A. Binding inner tie rod. Explanation: mechanical binding restricts motion in one direction. Number 15. A whining noise increases with steering effort and engine RPM. This indicates A. Low fluid or aerated fluid. B. Incorrect alignment. C. Clogged return hose. D. Excessive caster. Answer: A. Low fluid or aerated fluid. Explanation: cavitation in the pump produces whining noises. 16. Excessive play in a rack and pinion system is caused by A. Loose mounting bushings. B. Stiff steering coupler. C. Unequal caster. D. Low tire pressure. Answer: A. Loose mounting bushings. Explanation: the rack shifts in its mounts before the wheels turn. 17. The steering wheel does not return to center after a turn, which is most likely A. Binding lower ball joints. B. Incorrect toe. C. Faulty power steering pump. D. Weak stabilizer bar. Answer: A. Binding lower ball joints. Explanation: friction in suspension joints prevents self-centering. 18. Steering pull that disappears when swapping front tires side to side indicates A. Radial tire pull. B. Excess caster. C. Faulty rack seal. D. Worn pitman arm. Answer: A. Radial tire pull. Explanation: tire construction irregularities can create directional pull. 19. Fluid leaking from steering gear input shaft seal indicates A. Pump failure. B. Internal gear leak. C. Clogged filter. D. High camber. Answer: B. Internal gear leak. Explanation: leaks at input-output seals show internal hydraulic seal failure. 20. Steering wheel shimmy at 45 to 55 miles per hour usually indicates A. Tire balance problem. B. Worn stabilizer links. C.
incorrect caster, D, bent frame. Answer A, tire balance problem. Explanation: vibration at specific speed ranges usually stems from imbalance.
21. Caster is defined as A. The inward or outward tilt of wheels viewed from front. B. The angle formed by steering axis viewed from side. C. The difference in wheel track width. D. The relationship between front and rear toe. Answer: B. The angle formed by steering axis viewed from side. Explanation: caster affects directional stability and steering effort. 22. Excessive negative camber causes wear on A. Inner edges of tires, B. Outer edges of tires, C. Center of tires, D. Even wear. Answer: A. Inner edges of tires. Explanation: negative camber tilts the tire inward, loading the inner tread. 23. Unequal caster side to side causes A. Vehicle pull toward more positive caster, B. Vehicle pull toward more negative caster, C. Off-center steering wheel, D. Hard steering both directions. Answer: B. Vehicle pull toward more negative caster. Explanation: the car drifts toward the side with less positive caster. 24. Incorrect toe angle results primarily in A. Steering wheel vibration, B. Rapid tire wear, C. Excessive body roll, D. Pulling during braking. Answer: B. Rapid tire wear. Explanation: incorrect toe scrubs tread quickly. 25. SAI is used to detect A. Bent suspension components, B. Improper toe, C. Incorrect wheel torque, D. Uneven tire inflation. Answer: A. Bent suspension components. Explanation: since SAI is not adjustable, abnormal readings indicate bent parts. 26. A bent strut will change A. Caster only, B. Camber only, C. Toe only, D. Caster and camber. Answer: D. Caster and camber. Explanation: the strut's position affects both front to back and inward tilt. 27. When adjusting toe, the steering wheel must be A. Off-center, B. Centered and locked, C. Turned left, D. Turned right. Answer: B. Centered and locked. Explanation: centering prevents unequal adjustment side to side. 28. Thrust angle alignment refers to A. Relation of rear wheels to vehicle centerline, B. Difference in front and rear camber, C. Tire tread wear pattern, D. Axle weight distribution. Answer: A. Relation of rear wheels to vehicle centerline. Explanation: thrust angle defines whether the rear wheels push straight or sideways. 29. A rear solid axle misaligned on one side will cause A. Steering wheel off-center, B. Body roll, C. Engine vibration, D. Low power steering pressure. Answer: A. Steering wheel off-center. Explanation: a thrust angle deviation causes the car to track crooked. 30. Toe out on turns is necessary because A. Inside wheel travels shorter radius, B. Outside wheel travels shorter radius, C. Both wheels travel same path, D. It reduces scrub radius. Answer: A. Inside wheel travels shorter radius. Explanation: inner wheel turns sharper to follow a smaller circle. 31. Feathered tire wear across tread blocks indicates A. Incorrect toe, B. Incorrect camber, C. Overinflation, D. Worn wheel bearings. Answer: A. Incorrect toe. Explanation: misaligned toe scrubs tread and feathers edges. 32. Excessive positive camber will cause A. Outer edge wear, B. Inner edge wear, C. Cupping, D. Center wear. Answer A. Outer edge wear. Explanation. Positive camber tilts the tire outward, loading the outer edge. 33. Worn wheel bearings usually cause A. Growling noise that changes with speed. B. Engine vibration. C. Hard steering effort. D. Low brake pedal. Answer A. Growling noise that changes with speed. Explanation. Bad bearings rumble louder with wheel rotation. 34. Uneven tire pressure can cause A. Camber misalignment. B. Steering pull. C. ABS failure. D. Brake fade. Answer B. Steering pull. Explanation. Lower pressure increases rolling resistance, pulling the car. 35. Tire runout causes A. Vibration at specific speeds. B. Constant pull. C. Steering noise. D. Brake fade. Answer A. Vibration at specific speeds. Explanation. Out of round or wobbling wheels cause cyclic vibration. 36. Cross-rotating front tires on front-wheel drive vehicles helps A. Equalize wear patterns. B. Reduce rear brake fade. C. Increase caster. D. Decrease fuel consumption. The answer is A. Equalize wear patterns. Explanation. Crossing front to rear helps even drive tire wear. 37. A tire with a broken belt may cause A. Steering wheel wobble at all speeds. B. High-speed shimmy only. C. Clunking noise in corners. D. Excess caster. The answer is A. Steering wheel wobble at all speeds. Explanation. The tire becomes distorted and vibrates constantly. 38. After tire replacement, vehicle pulls to one side. Likely cause. A. Radial pull from construction difference. B. Incorrect toe setting. C. Bent spindle. D. Uneven caster. The answer is A. Radial pull from construction difference. Explanation. Even new tires can have built-in bias that causes drift. 39. When installing aluminum wheels, it's important to A. Use impact wrench at max torque. B. Tighten lugs with torque wrench in star pattern. C. Lubricate lug threads heavily. D. Reuse stretched lug nuts. The answer is B. Tighten lugs with torque wrench in star pattern. Explanation. Star pattern ensures even seating without rotor distortion. 40. Wheel lug nuts should be retorqued after A. Every 10,000 miles. B. 25 to 50 miles after installation. C. 500 miles. D. Never necessary. The answer is B. 25 to 50 miles after installation. Explanation. Retorquing ensures proper seating after initial use.
41. The steering angle sensor is used by A. Airbag system. B. ESC and ABS systems. C. HVAC blend doors. D. Charging system. Answer. B. ESC and ABS systems. Explanation. Steering input is compared to yaw and wheel speed data for stability control. 42. EPS systems provide assist using A. Hydraulic pump. B. Electric motor. C. Engine vacuum. D. Air compressor. Answer. B. Electric motor. Explanation. Electric power steering replaces hydraulic pressure with a motor-driven assist. 43. A failed vehicle speed sensor in variable assist steering causes A. Too much assist at high speed. B. Hard steering at parking speed. C. ABS failure only. D. Loss of engine power. Answer: A. Too much assist at high speed. Explanation: without speed input, the system stays in full assist mode. 44. In a hydro boost system, assist is lost if A. Steering pump belt breaks. B. Vacuum hose leaks. C. Alternator fails. D. Tires underinflated. Answer: A. Steering pump belt breaks. Explanation: Hydro Boost uses steering pump pressure, so belt failure removes assist. 45. A driver feels the steering wheel shake when braking. This indicates A. Warped rotors. B. Worn tie rods. C. Uneven caster. D. Low fluid. Answer: A. Warped rotors. Explanation: uneven rotor thickness causes pedal and steering vibration.
46. If power steering assist is lost intermittently, check A. Fluid level, belt tension, and pump output. B. Camber angle. C. Ride height. D. Brake fluid level. Answer: A. Fluid level, belt tension, and pump output. Explanation: all three affect steering system performance. 47. An EPS system with no assist and a warning light on likely has A. Faulty torque sensor or motor failure. B. Worn ball joint. C. Incorrect toe. D. Low tire pressure. Answer: A. Faulty torque sensor or motor failure. Explanation: EPS needs torque input. Sensor or motor faults disable assist. 48. A faulty yaw rate sensor will affect A. Cruise control. B. Stability control operation. C. Engine timing. D. Fuel mixture. Answer: B. Stability control operation. Explanation: ESC requires yaw rate data to correct vehicle movement. 49. A popping noise during slow turns with EPS could indicate A. Binding strut bearing. B. Bad torque sensor. C. Low hydraulic pressure. D. Faulty rack bushings. Answer: A. Binding strut bearing. Explanation: popping often comes from mechanical binding rather than electronics. 50. When flushing a power steering system, always A. Use automatic transmission fluid, any type. B. Use correct manufacturer-specified fluid. C. Mix fluid types to improve performance. D. Run system dry before refill. Answer: B. Use correct manufacturer-specified fluid. Explanation: the wrong fluid type can damage seals and the pump.
Thanks so much for studying with us today. I hope these practice questions helped boost your confidence and sharpen your skills. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell so you won't miss the next study session. You can click the links on screen right now to watch another study video and keep your learning going. I'll see you over there.